Hi, everybody. Thank you for joining us today in podcast volume 2, episode 6. Today, we're going to be talking about how filament is made. So kind of walking through that manufacturing process and the results of that. With me today, as always, is Brad Woods, our CEO, the inventor of filament, and our all-around general science guy here at the Virtual Foundry. So before we get started, I'll let you know that today is Friday, April 16th, 2021. The time is 10:39 a.m. and our temperature outside today is 48 degrees Fahrenheit. That's 9 degrees Celsius. Still kind of chilly. We're working with it, but we're still waiting for those nice spring temps to kick in. So Brad, today we're talking about how filament is made. And the basics of that process is that you take some metal powder, you mix it with your proprietary plastic binder. Those go into an extruder. That extruder mixes, it heats, it turns the material, and then it spits filament out onto the other end. So tell us about the powders and the properties of the powders that you use.
Right. We've been experimenting with this I have since 2014. So we've gone through many iterations of what is ideal and what is the best powder, and essentially, and also what's easiest. Some powders are more difficult than others, and it comes down to a variety of factors, including particle shape, particle size, particle surface area, and often a large part of it is a powder that has what's called a high apparent density. So it's a volume of particles that is very dense as you can get it. And what I've discovered, or kind of how it's come along, there's actually a science behind this geometry. It's called sphere packing. And interestingly, there are some theoretical ceilings on how high you can actually pack particles into a space. If all the particles are the same size, you, in theory, can't exceed about 74% by volume, which is really interesting. And I've spent the last couple of years figuring out ways to overcome the limitations. And we've done that by developing blends of different sizes of powders, different sizes of particles, and things like that. So that's one of the ways that we've kind of taken our material to the next level. It's tempting to think of our filament as our materials. It's tempting to think of it as plastic with metal added to it. But it actually makes more sense if you look at it the other way around. What we're doing is we're taking a volume of powder and adding just enough thermopolymer to it to hold it together. And I have some pictures that will help illustrate this. So this is actually, quite an old piece of media that we did, but it illustrates the point. The parts at the bottom are both unsintered, so they're considered green parts, but the one on the right is polished. So, there's enough metal in the stuff that you can print it and polish it, and it looks shiny and looks like metal, but that's all kind of beside the point. If you look at the images above, the first one is, these are individual print layers from a 3D print. Above that is just a bit more detail, and above that is more of a microscopic look. And I'll go to another photo. In this one, you get a pretty good idea of what's going on. Those are millions of copper spheres coated with a thin layer of thermopolymer and held together into a filament. So this image is literally a microscopic image of what our material looks like if you look at it very closely. It's millions of very shiny, very spherical particles with a size distribution that optimizes how much we're able to pack into a given area.
So the goal with this all along has been to get the most powder into the filament as possible, but still having the filament be 3D printable. So how do you find that balance?
Right. And this has been a key struggle from the beginning. It's very easy to make a filament that has a lot of metal in it, but it would just be so weak and so brittle that you can't handle it and you can't get it through the printer. We've overcome this in a couple different ways. The biggest change has been developing a thermopolymer. So our strategy here is proprietary. It's part of what we consider our secret sauce. It's developing a polymer binder that even when there's very little of it, it will adhere to the particles very well and be somewhat flexible. So this is a back and forth that we've done for several years. As we've improved the polymer, we've been able to increase the amount of additive, the amount of metal in the material.
So getting that amount of metal into the filament and still having it 3D printable is a delicate balance. So one inherent property of our materials is that they're just a little more brittle than standard PLA, for example. But we find ways to manage that brittleness. So Brad, tell us about, well, first of all, in-house here, one way that we manage that brittleness is to use larger spools. So if you've used our material before, you've received it in the mail or by UPS, and it's got one of these larger than standard filament spools. So this is a blank spool that we'll put some product on later. And if this size and shape looks familiar to you, that's because it is a familiar shape. Brad, show us the first prototype of our special spools.
So this is where I started. And so it's a piece of concrete cardboard tubing in the center with a Disney album on one side and Barbra Streisand on the other. So this is still the shape and size of the spools that we're using now.
Oh, and thanks to Babs for helping out in the development of that packaging process. So tell us a little bit, or we do have a couple of ways that our end users can also manage that brittle nature of the filaments. And one is through the Filawarmer. So talk us through that, what its job is and how to use it.
Right. As the material, and this happens with any plastic or thermopolymer, as it sits on the spool, it develops a memory that's in the shape of that circle. So what we've done is we've created a small device that, as the material comes off the spool, it hangs there and it warms it up slightly. And this is a very simple device. It has a thermostat in it that keeps it at about 65 degrees. So it'll cycle from 55 to about 70 degrees Celsius. And this change in temperature, raising and lowering it, does two things. It removes that memory and makes the material straight. But it also takes advantage of an interesting property of polylactic acid, and that is that you can anneal it. So raising it to this temperature and holding it there gives the polymer chains time to sort of restructure. So it actually comes out of the Filawarmer stronger than it went in. So people's natural question is, why don't we just do this with all of the material that we send out? And what we found is that if you heat, this effect really only lasts about 24 hours. And after that, it'll actually be more brittle than it was before it went through the Filawarmer.
Okay, that's a great note. So that's why we advise people against sort of baking their whole spool at once,
Yes.
unless they're going to use their whole spool right after it comes out of their heat source. Because as you said, that effect lasts about 24 hours and afterwards it'll be even more brittle than when you started.
Yes.
So really important to only heat that one strand at a time as it's coming off the spool.
Correct.
Brad, walk us through the history of filament and how you even got started making this stuff.
Right. Yeah, this was a project that was a hobby that became a profession. I was originally working with methods of creating metal pieces without using high heat. So methods of creating a metal object or a metal sculpture without having to heat copper to its melting point. I came up with a variety of strategies, some of them using electrolysis, which is like electroplating and electroforming, things like that, where you're dissolving the metal chemically and then putting it back together. At some point, I started working more with powder metallurgy, where I was making clay that you could sculpt with metal powder and then sinter that into a into a solid object or into an object. At some point, I discovered 3D printing and realized that there was an obvious potential to combine these things. So that set me on the quest. I think we have some pictures somewhere of my ancient first attempts at building an extruder. It started very simple, very crude, and I spent a lot of time at the hardware store buying parts.
Yeah, so you can see on the lower right your homemade extruder, which is a totally normal thing for someone to have in their basement.
Right. And actually that extruder was successful enough that I was able to make materials and get it 3D printing and put out prototypes that I could show for Kickstarter. And we did our initial round of funding through Kickstarter, and it was we raised about 107% of our goal.
Great. So we talked a little bit about the history. Let's talk about the future. The future of manufacturing filament includes expanded materials. So Brad has done some experimenting with glass. We've also done some custom filaments for our customers. And because the manufacturing process and the materials that go into each filament are the same, the base material changes, but the other materials included in the filament is the same. The manufacturing process is generally the same. That is also how they print very similarly from material to material. So because of that established process, we are able to take many other different kinds of alloys and different kinds of materials and put them into this 3D printable format.
Right. And that's one of the most interesting things about this project is the breadth of the technologies that we touch. We're in just about everything you can think of, everything from X-ray, nuclear medicine, radiation, nuclear power, fusion and fission. It just keeps kind of going on and on. Essentially, we've developed a process that you can plug infinite materials into. So we can take nearly anything, assuming that we can source the appropriate powder material, we can make that into something that can be 3D printed. And we've done, very peculiar things, like things that are analogs for human bone and X-rays, things like that. Just so many things that I never would have imagined, but it's strange is becoming normal to us. We're breaking new ground here all the time.
Right on. Our customers are doing such a wide variety of really cool stuff with these materials. Now, thinking about manufacturing filament, could you 3D print a 3D printing filament?
Yes, I've thought about it, and you might need to augment the printer a little bit, but yeah, absolutely. In fact, you could convert from one size filament to another, things like that. Sure.
Wow, awesome. I mean, 3D printing in general just opens up worlds of possibilities. I do have one more very important question for you, Brad, before we wrap up. Now, did you hear about the mathematician who was afraid of negative numbers?
No.
Well, he'll stop at nothing to avoid them.
Nice.
Well, that's our podcast for today, folks. Thanks for joining us on this journey of how filament is made. We'll see you next time.